Oh yeah, that's what we're here for. Do you think it's possible to make a 3D printed engine run long enough to melt the plastic?
That's a great question. I hope we find out someday. Okay, did you guys talk about concrete work yet?
No.
All right, so we just poured this concrete yesterday. We're putting 6 new horizontal machining centers in. And so the concept here as we expand our markets, expand our offering, we want to machine more blocks in-house. So this concrete's less than 24 hours old, and hopefully the next time you guys come around there will be new CNC equipment here. That'll allow us to do our new block, small block Fords, in addition to the Chevy derivative stuff that we're machining today for performance and industrial applications.
Josh, how thick is the concrete?
I think it's about 2 foot thick.
2 feet?
Yeah. So they dug it down. There's a pit this big, and then there's just rows and rows of rebar in there to provide it with structure. One of the things that helps us with is it helps us be more precise in our machining.
Does that actually make a difference?
It actually does. If you don't have thick enough concrete over time, you know, with the vibration from the machines and everything, if you don't have proper support, it can settle or crack, and then you're having to go in, realign the equipment to make sure all of the finished dimensions are inspected.
Oh, something I thought of, I'm just running through here. What are comments that I had seen a lot from the first video? And what comes to mind is people did not understand the concept that for the small block stuff, everything was machined within a certain tolerance that you can just put it together without checking it. They didn't seem to think that. They're like, oh, they didn't even check this, they didn't even check that. So maybe we could explain that. Okay. And the big long line hone, people kept saying like, oh, well, how does that work? It's big and long and it has to flex. I'm like, well, I don't know.
We've got some guys back in engineering that can talk to you about the align hone. For a lot of our processes, we're QS certified, ISO certified. So what that means is we've got gauges and inspection plans that tell the operators what frequency they have to do those inspections. So we check the bore, we check the main journal, we check all of the bolt holes. And then we've got a CMM where we pull blocks out of production and go back and do an inspection to make sure everything's still in alignment.
That's what I thought, but I guess that's why people ask questions. That's why there's a comment function.
Yeah, no, that's good. And you know, your viewers aren't any different than our customers. They ask us the same questions.
Just show them the heat, or have them feel the heat. Yeah. Feel the difference in the heat coming off that concrete.
This is cooler than it was this morning, but if you feel that heat, you can feel the heat rising off of it.
Yeah, is that just from it drying?
Yeah, so yesterday they started mixing concrete at like 3:30, 4 o'clock in the morning. That's when they brought it in, started pouring it. By the time we had moved to the next section, that side was already starting to dry out and set in due to the heat. Yeah, there's a lot of things that we have to do. Your viewers have lots of questions, but so do our customers. Mm-hmm. So on the machines, we've got control plans. We've got a gauging station where we do an inspection. And then as part of the final check before assembly, the blocks are inspected 100%. We make sure that the bore and the deck height and the align hone are all in spec. So you can see the gauging station there. Every block that we machine, that piece of paper is for the next block to come out. So when the operator does their inspection, they'll record critical dimensions and then they'll sign off that they completed the check.
Okay. Yeah, I think some people probably just thought, oh, you just run that through there and put it together. Like,
yeah, no, that's not how it works at all. Our customers, you know, they require a high level of precision and accuracy, and so that's exactly what we demand of ourselves. So since the last time you were here, we've moved machines around, we've increased our capacity, and then that was before we actually purchased new capital and equipment to come in. Now, due to the demand that we've had, our sea of blocks is actually lower because we've been going through and producing at such a high rate. And even with the level of production that we're doing, it's really difficult for us to keep getting everything out as quickly as we want it to.
So you could say it's low tide.
Yeah, exactly. We're trying to get it built back up. One of the things that you asked about, it's not for this block, he's not running it now, but we use air gauging in the plant. So after a block is machined, we'll actually go through and use the air gauging to check the main journal. So you know, when he's machining, he's actually using a dial bore indicator gauge to go in and do that inspection when he does the manual machining. But for a lot of our automotive machining, one of our checks would be to go through and do an inspection of the main journal. The air gauge is a lot more dialed in, so you can set it up and not have to change it as much, as opposed to this one, you've got variability and different setups for the different types of main journal diameters. This one, you can change the ring gauge and change the settings and get it programmed, and then you can go through and do an inspection.
That's cool. I think this is all really, really useful for the, I don't know, just the nitty gritty of it. That video is still 47 minutes long, but you can't fit all of it in there. We could have had a 4-hour version of, and it still wouldn't have had everything in there.
Yeah, that's, you know, our goal is every time.
We gotta, wait, hold on.
Todd?
Yeah, we gotta do the hair flip here.
How you doing?
Oh yeah, that's what we're here for.
How we doing? How you been?
Never better.
Thank you.
Well, that was necessary. Okay.
Yeah, I was gonna say, he's actually become his own screensaver on a computer, so it's immortalized in time. If it ever changes, we've still got a good image of Todd.
Can you put that as like the background on the website for like a day? National Mullet Day?
We might have
That's a good idea, actually.
Yeah, we don't have the Fort Wayne Mullet Man, but we've got Todd. I don't know if you guys are familiar with the Fort Wayne Mullet Man.
I don't think so.
There's a Facebook web page, and they've got him, and this guy shows up around town, and he's a celebrity where people take their pictures with him, drink beer with him. We got lots of guys that want to say hi to Todd. Yeah, our goal every time we bring people through the plant, you know, if they've gone a couple of months since their last visit, we try to continually change and upgrade our facility. So in the area that you're in now, we did the piston ring installation last time. We've also increased the capacity of the line. We're running multiple shifts, but then we also do things like move installation to help with flow. So you can see the blue racks are in place again, built by the operators to go along with the stations for what they need. And as we go around the other side, you'll see we've added some new operations into the line.
Hey Josh, the other thing, I think the lights are new.
Yeah, so Jeff, where's your lights, buddy, right here? So when we're running on the line, you've got different lights you can flip. So we can turn a light on for QC. And if the light's on and somebody's walking by and they see it, they'll know that we need support at the line. And then the other line tells you if there's a parts outage. What that allows us to do in the plant is any manager walking through at any time can see that, see if there's an issue that needs addressed. So if the assembly supervisor isn't here, one of us can stop in and help out.
Something else I just remembered is I don't think some people grasp the concept of how you design and have your own parts produced to be put in here that are proprietary yours.
Yeah,
and how that relates to like GM. Like GM doesn't cast their own pistons; they get them from somewhere else because they design them. Like,
right.
Can you explain that similarity and how that actually works?
Yeah, so we've got an engineering design department. We'll do designs based off of necessity, based off of customer requirements, and we'll also do it based off of ease of manufacturing. So these are our cylinder heads. You can see it's got our BluePrint logo on them. And so those are made specifically for us to our design. We've got a couple of different styles that those are used for. I think we've got 3 different individual part numbers on the industrial side. We've got performance side. You keep going, don't let us stop you. And so as we go through and make design improvements, one of the things, you know, that's specific, or that, you know, this has the ability to take a center bolt valve cover and a perimeter bolt valve cover.
Oh yeah.
So
that's,
you know,
really
as
neat.
we increase the number of perimeter bolt valve covers that we use, we're actually going to make the product specifically for the perimeter bolt, and we're also going to make provisions to have a center bolt. So with some of the TBI engines and some of the older style, you know, Vortex style heads, that they take that center bolt, we still want to accommodate that, but a lot of our production is set up specifically for that perimeter bolt. Last time we talked about pistons. So when we developed that piston installer, we actually worked with the piston manufacturer to change the ringland location so it could be more consistent, so we could put more engines through and use that technology.
And those are, when those engines go through there, the small block Chevys, that is the same engine every time. That is like for the industrial stuff.
Yep.
I think some people don't know that, really discern the difference, that a lot of the stuff in here is the same unit for an industrial application, so every piece is the same every time.
So a lot of what we do, there will be differences, like in chamber volume, there might be differences in how the intake mounts up, but at the core, a lot of the engines have a lot of similarity. Where the differences happen really are the components inside of the engine. You've got different pistons, you've got different types of material of pistons, different styles of rockers, things of that nature. So conceptually, the block is going to be the same for everything that we produce on the mounting surfaces, but internal to that, it's different for all of the different applications that we have. Does that make sense?
Yeah, it does. Because there's, you know, in people's heads, a crate engine is, it's performance, it's supposed to be custom every time, but they don't understand the volume. Two, they don't understand, or maybe they didn't catch the part of the industrial stuff that's very similar unit to unit.
There's a lot of commonalities between it that allows us to produce them in similar operations as we go through, Mitch, but there are differences. So like we've got different styles of engines. They have different compression ratios, different, you got a one-piece rear seal, two-piece rear seal. So there are some specific differences in the application due to the add-on components and things you can pick. But the rest of it, you know, it's not that different to install a cylinder head if it's got a different internal design and a combustion chamber, for example.
Yeah, exactly.
Some of the other things you can see, the long block on an industrial engine like this one is going to be the same. It's going to be like, for this engine specifically, the industrial block is very similar. It's a 10.3 liter engine. It's very similar to a 632 cubic inch engine in terms of production, but what goes inside of it is different. Then you have different configurations. You've got, you know, different pulleys based off of what customers need. The water pumps will be relatively the same. The coils, the ECM, that's where it starts getting different based off of the application. We're in a state of transition, so this setup has only been this way for about 2 weeks, and it's probably gonna last another 60 days, and then as we moving pieces around the plant, the layout will change. So as we go through here, this is a fairly temporary location for a lot of the stuff.
But when you have this change planned, how long before you actually start moving stuff do you plan out, okay, this thing's gonna go here, we're gonna move this line over there, you're gonna go this way? How is that all mapped out before you move things?
We start doing the plans probably 12 months to 6 months before we actually do the move. And then as we go through and do different revisions of the plan, that's how we finalize stuff. So like this layout was finalized probably about 2 weeks before we actually put it in place. So, you know, we put a staging area for industrial engines. You can see that the operators go through and get stuff prepped up for installation. So instead of the guy at the line doing the assembly, unboxing everything, we've got people who will unbox it and stage it so that way they can be installed more quickly in assembly. The last time you guys were here, we were installing intakes, distributors, carburetors, things of that nature all down here. Now that's moved back up into the flow of the assembly line. From there, the dyno operation is still the dyno operation. Every engine still gets a dyno sheet. Every engine still 100% dyno tested for us. You can see more integration of the blue rack. So, you know, as we gear up, we've added a third shift to help try to increase our dyno capacity and give us more flexibility. So, you know, a lot of high-level changes from the last time you guys are here, but we're still making as many good engines as we can.
Whenever you're under phases of transition like this, does it slow down production, or have you ever gone to change something, move things around and thought, wow, this weird way actually works better than we had it before. We're just gonna kind of leave it like that.
You get both. So like for example, this move here, this box that has the dyno and all of the computer equipment in it, it was picked up on a Wednesday afternoon. Our engineering team worked, you know, they split shifts and they worked long days. During the day they worked overnight, and they divided up as much of the work as possible to minimize the downtime. So, you know, in some environments you would look at that and say that's a 2-week move, and we moved it on a Wednesday, and by Friday afternoon we were starting to fire the first engine in it. So that's more downtime than I want, but I also consider the effort by the team to be world-class in terms of what they did to minimize how much time we were down.
Josh never has a problem with change. It's real easy for him. He can always keep the same level of production going no matter what you do.
Exactly.
Is that why you start planning a year in advance before you move anything?
Exactly. Yep.
It's kind of an inside joke we have. Every engine's the same. Everything's easy for Josh. He'll deal with anything.
Well, that's your background, isn't it?
That's what, you know, we try to do a great job at solving problems and working together as a team. And with the team that we have, we really couldn't have that mentality to have people be, you know, they adapt very well and they pitch in and they help out. And as soon as we get something going, our operators in the shop that have to deal with it, they're the first ones to try and help us do a better job. That helps make our willingness to change easier too. Without the team that we have, I think it would be a lot more difficult, but people really do care and they want to be a part of help making us change and grow for the better.
Did you see production dynos last time you were here?
Yeah, we did.
Okay.
Yeah. And so if you're watching this video, there's a whole other video before this on my channel for like the main factory tour. This is kind of just filling in the gaps, checking out new stuff. So if you haven't seen that, go over there and watch those too.
What other questions do you have?
Is there anything new cool in the R&D dyno room? That was my
well,
favorite part last time.
We're gonna go back, we'll take you through. I think QC is relatively similar to what you guys had the last time you were here, so we'll go to engineering, let those guys show you what we're doing back there, and then we'll head on over to R&D.
All right. For people who don't know, you're the brains behind a lot of this stuff.
Some of the brains, yeah.
Some of the brains.
Frank Romadka, I'm the lead engineer here on the design side. So this is the 302 Ford block that we designed.
Yeah, I didn't see this before.
Yeah, we based it on a OEM Ford block. Looked at some other aftermarket blocks out there, then we also incorporated a bunch of stuff that we wanted in here. Like we set it up so we can have piston oilers in here like LS blocks have. We set it up so the bolts can go all the way down to the superstructure of the block, much like what an LS has. Really done a lot of cool stuff to upgrade it and make it stronger and better for us.
So I'm not a Ford guy, so I can't remember. Do you currently sell your own casting Ford block now?
Nope, we don't.
Oh, so this is coming out.
Yep, this is our new thing here. That's going to be pretty exciting. Before we used either OEM Ford blocks or maybe like a Dalton block. So this will be all ours here, just like our small blocks and big blocks are.
So I would venture to guess that this one will not break in half at 500 horsepower.
This will not break in half at 500 horsepower, guaranteed.
Is this 351 or 302?
We're doing both.
Both of them.
That, yep.
How big can the 351 one go? That's what I want to know.
I'm not exactly sure how big that can go right off the top of my head. Have to get Chris in here and ask. I know the 302 can go up to like 363 somewhere.
Yeah,
in
I
there.
think at least go to 427.
Oh yeah.
That would be cool.
Gonna need one of those next.
Yeah, one of the things we're struggling with, I think the whole industry is cores and being able to get the small block Ford cores. So it got to a point where it just made sense. We could see that coming, and it made sense to make the investment and tool up for our own casting, which it's going to be great for us.
Yeah, if you want to hear him talk a lot about what he does, there's a whole video, there's a factory tour, and then there's a whole video just in here with mostly you talking about the R&D, like design stuff.
Yep.
And you had some really freaking fancy CNC parts washer thing here what you were working on.
Yep, that's out in the plan now.
So it's actually working.
Yep, that is working.
We'll
now.
take you to it.
Yeah,
We'll show it to you.
we need to go see that thing.
All right. Sounds good.
When did you put that into operation?
You remember when that was, Sean?
I don't.
Yeah, that's one more of the manufacturing guys things, so I've been involved in that one.
Frank, anything else new that
with
recently
OS
been working
oil
on?
pan. I don't know if you've seen that.
No.
Our own LS oil pan, new. A lot of people have been wanting this. Just another thing that we can use on our engines. That
Is that like a swap pan that would work on GM A bodies and clear steering racks and all that stuff?
Exactly. So just our own version of it.
So I see you got all kinds of baffles cast in here. I could be wrong, but I have not seen those in other oil pans. I mean, they got this plastic, not plastic, but the piece of bolts on here, but these big cast walls.
Yep.
I haven't seen that.
Yep, that's in there just for people that are doing like autocross racing or road racing, and when you have a lot of oil sloshing from one side to the other, it keeps it in that area of the baffle so you don't lose all your oil. So
That's really cool. You sell these components individually too, don't you?
these probably aren't out on our website yet, but they probably will be soon.
Okay, so you don't have to have the whole engine to get parts that you guys make too.
Exactly.
We prefer to sell the whole engine though.
Yeah. So what I'm wondering is, last time we were here, they had this whole 3D printed engine. And I thought, I wonder if you could shove spark plugs in that thing and see how long it takes to melt. Do you think it's possible to make a 3D printed engine run long enough to melt the plastic?
That's a great question. I hope we find out someday.
I want to do that. I'm not going to let that go.
Can you give Chris a call and ask him to come back here? Guys, you're fine.
I'm
It's
gonna take
lunchtime.
off,
It's
guys.
okay.
Good seeing you again.
Hey, you too.
Take care. Enjoy your time. Hopefully
glad.
Chris will have some really awesome stuff to show you back here.
I think so. I like the OG sign up there. That's
Yeah.
cool.
Our roots. Want to do some push-ups first?
Yeah, so got some new prototypes going together for some forestry product right here. Gasoline-based engines. They do things like chop up wood, grind stumps, things like that. Last time you were here, we were working on a coyote killer, so we're getting pretty close on that. ECM calibrations, all that stuff's kind of done. We've got the final packaging just about completed. We've got a few more things to sort out on it. We're actually going to develop our own intake manifold for it, we've decided. So we're going to start with this, but we'll end up with something different. Working on a Bonneville engine build over here. It's a 364 LS engine, CNC ported heads, hoping to make about 1100 horsepower, twin turbo. What size are those turbos, Lance? 75 millimeters, 2 of them. So that's kind of fun. Got a new 350 TDI replacement engine that we're going to be launching here pretty quick. So the guy that's got the 88 to 95 Chevy truck wants a new replacement engine that makes more horsepower over the stock one. This will make about 300 horsepower closely to that. So that's a new product we've got coming out. We've got a new 454 big block that we're going to be releasing, so it's lower compression, milder cam, something for the guy that doesn't want all the horsepower. He just wants a nice tame big block. So that's going to be coming out pretty soon. We've got some new industrial genset engines that we're going to be releasing here pretty quick.
That's a little turbo.
Yeah, it's a small turbo.
Making boosted idle. No, I didn't even spin it, you're right. Those are the rules.
So we're going through an air to boil test in here. So we're doing a coolant size test, making sure our radiator is going to support the power levels that we plan to put this engine through. Well, that's what's happening there. Nothing fun.
Are you just heating water and pumping it through there without actually running the engine?
Yeah, exactly. So, well, no, we're gonna run the engine. So, so we'll run the engine at full power for an hour. So we're gonna make sure everything's heat soaked. We're gonna make sure that the cooling system with maximum ambient temperatures that it's gonna see is actually gonna support the cooling system and not overheat the engine.
Okay, that's cool.
This one's kind of fun over here.
What is that?
So this is a new heavy-duty engine that we're getting ready to launch. This is going to be used in applications like generators, pumps, stuff like that.
Tanks?
Yeah, maybe not tanks, but it's going to run off natural gas, propane. It's a 24-liter engine that's been converted over to run on natural gas. We've designed a ton of the components in it. It's actually not an engine that we build, but we did have a huge part in the development of the components inside of the engine, so it's going to work for the application that we put it into. So turbo sizing, fuel system, pistons, camshaft designs, I mean everything down the valves, seals, seat materials.
The 24-liter V12.
Yep, exactly.
How much power and torque does that make?
What are we going to make on this at 1800? About 2,500 foot-pounds of torque, roughly. 2,500 foot-pounds of torque. Basically idle.
I just see that. It reminds me of those big, like Merlin tank V12s, the World War II ones. I think they're, I don't even know if they're that big though. That thing's huge.
Yeah, it's about 6,000 pounds, roughly.
God.
And we're going to be selling this complete with a radiator package and everything on it. So,
will it fit in a Honda?
Maybe.
I was just making the joke, like, you know, people are like, will this fit in my Honda?
Probably not.
No, it won't.
It might be as big as your Honda.
You saw that last time you were here?
Yeah.
Plastic printed 3.6.
Yeah, so yeah, your last video, we were showing you the prototype that we were working on. Now we've got it in the dyno cell. We're getting ready to run the actual engine.
So look at the real one here. Oh, it's still got an even tinier turbo.
Yeah, so we're just getting it instrumented. Obviously, we've got tons of data to collect off of it because it's our very first prototype. It's, you know, all of the first article components are on this build, and we're getting ready to do the initial development on the cowl and start putting some time on it. So we've got a lot of work to do.
So that's a small block Ford head.
Ish. It's like a small block Ford head, but it actually has a lot of changes that we've made to it to work on an engine like this. We're gonna push the power density on this engine pretty darn high, so we had to alter the castings, had to add piston oilers. I mean, there's just a ton of special pistons. There's a ton of things that we did to this to help it survive the applications that we're going to be putting it into and the power levels we're going to be pushing it to. It'll be the highest power density engine I think we've ever built. Horsepower per liter.
How much power is it supposed to make?
Turbocharged on gasoline at maximum RPM of 2,800. We're hoping for about 145 horsepower out of a 3.6 liter. So, which probably doesn't seem like a lot to your crowd, but the market we're looking at it's a lot.
All those things do is spin. They don't typically make a whole lot of horsepower.
Right. Yeah, and the RPM is really low. But yeah, you can see we've got instrumentation all over it. We're going to be collecting a ton of data off of it. And once we do some initial calibration work, we're going to stick it out in our dyno cell out back here and do durability testing on it. So this engine will go through, the first couple will go through a couple 500-hour tests that are about an 85% duty cycle. So we'll be running the engine at full load for probably 100 hours of that 500 hours roughly, and then it'll be partial loads throughout the test.
Chris, is anything running on the durability cell?
No, but we can take them out there.
We should, because that's new. We didn't show you that last night.
Oh, yeah, I don't think so.
There's that one running if you want to see it run.
Oh yeah. Is that at full bore? 1,500 RPM?
No, it'll be running at 1,800 RPM.
Oh.
He's just doing some initial cow work right now.
Oh, we definitely did not go out here. Look.
about 2 months ago, we finally got these two cells operational. So what we'll do with this is basically just put engines out here. We'll run them for 24/7, just to get time on them, do endurance testing, durability testing. Right now we've just got a unit on there that we're doing some cooling sizing on, really just getting the durability cell set up and making sure everything's working correctly actually before we get 3.6 engines put in here. So we've got two sides. The reason we wanted to do this is, you know, the testing like this takes up a lot of time. It takes up a dyno cell that we need because we're developing a lot of new products, and it keeps it out of the building. So we're not going to burn the building down if something goes wrong. I mean, things go wrong. So
Yeah.
we'd rather something go wrong in a small box like this versus inside the building. So
That makes sense. Why tie up a dyno when you don't need the dyno part of the dyno? You just need it to run.
Exactly. We need to be able to put load on the engine. We've decided an alternator is the best way to do that. It kind of limits us on RPM ranges for now, but maybe at some point we put something in here like a water brake or an eddy current dyno or something like that, to where we can change the speed of the engine. But we've found that heavy loads at low RPMs are maybe what kind of kills a lot of this stuff anyway. So yeah, that's what we decided to do.
So we just did a bunch of filming in here. This will be the resume of today's race week video. We're gonna pull Uncle Rob over around back and put new spark plugs in there, and maybe somebody can take a look at that AC compressor that knows more about what they're looking at than I do, because I don't really mess with that stuff, never had to before. Now this factory tour video was a brief version, just kind of covering the updated things of stuff that has evolved since the last time we did the full-blown tour videos. There's a main tour video. It's literally like 45 minutes long of the entire process from the bare block to the box that goes out the door. You're gonna want to check that out if you haven't seen it before, because it's really freaking sweet. They even let me use the engine dyno and show you my engine at the end that I took home with us. There's that. There's other videos. There's a whole BluePrint playlist on my channel, so go hit the subscribe button and check that out. And if you're wondering why there's absolutely no merch on the shelves right now, because it's all going to Street Car Takeover Charlotte with us. You can still order all that stuff on stapletonautowworks.com, but you can still order it and we'll send it as soon as we get back. Ruger can't even ship it because he's coming with us too. So yeah, we got Elvis shirts, Good Ranch Pit Crew, Uncle Rob, all that stuff. I'll give you a look here. This is the Uncle Rob shirt, the OG flag shirt and hoodie. And we got these in all the sizes too. Those ones, we only have them in 3X and 4X, but I believe they're still on the website. If they're not, then I probably took them off because of the limited quantity. I didn't want to sell them in person and then have them not be on the website at all. So, gotta jump on things while you still see them, because they're always subject to change. Like these hats, the ones I always wear, they're on the website too. We have enough of those to ship them, but if we sell them all in Charlotte, I'll order more. Jump on that, check it out, check out the BluePrint playlist, and yeah, say drop a thumbs up for dog stuff. What are you doing? Woof. If you're wondering why he has one eye, it's because he was running around and he hit it on that electrical outlet on that pole right there. So that was not a fun time. Okay, well, I hate to end on a sad note like that, but go check out some other videos.